Dear friends, welcome to this electrical engineering knowledge sharing channel. We are discussing about the switchgear control schematics under workshop 8. We have already completed 3 sessions, and under this channel we have total 64 videos, and today's videos is a 65 where we will be discussing about the session 4 under workshop 8 to demonstrate the tripping schematics of a circuit breaker. Now, under this workshop 8, we have already completed 3 sessions. Session 1, we have discussed about the various parts of the control schematics. Second part, that is under session 2 and video number 63, we have discussed about the closing schematics of a circuit breaker. And then we have made a small video under video number 64 to discuss about the anti-pumping scheme or features of a circuit breaker closing circuits. After that, we are switching to this next scheme, that is your tripping schematics of circuit breaker, and this video will be video number 65. Let us discuss about the tripping schematics. Now, when we are going to discuss the tripping schematics, actually this schematics has a two part. One is opening scheme, another is a tripping scheme. Now, in the circuit breaker, we generally call it tripping scheme, but actually I have divided the scheme in two parts. One is the opening part, another is a tripping part. The difference between this opening of a circuit breaker means it is actually when we open the circuit breaker from the closed position knowingly. That means by manual intervention, when I open the closed circuit breaker just for operational purpose or for testing purpose or any other operational reason or maintenance purpose, at that time we are opening the breaker, but there is a healthy condition of the circuit which the circuit breaker is feeding power. But to do the maintenance work or any operational reason, we are opening the breaker. That part we call is opening operation or op operation. But there is another operation of a circuit breaker, that is when there is an abnormal condition in the circuit or in the switchgear panel itself in the power circuits or the remote end where this circuit breaker is feeding power. If there is an abnormal condition of the remote end equipments, or it may supply power to the remote end switchgear, if there is an abnormal condition, then this circuit breaker need to trip automatically. When this due to abnormal condition of the circuit, which is by which the circuit breaker is feeding power, or there is abnormal condition at the remote end, whatever the abnormal condition, under that abnormal operation condition, it could be circuit fault, it could be overcurrent fault, it could be short circuit fault, it could be differential fault, any type of fault or abnormal condition, as well as if there is some abnormal condition in the other remote end where this equipment is not directly subjected, but there is a other equipment where there is a fault, that fault could cause a problem to this, then also we need to open this breaker. And if that abnormal condition, if the breaker is open, then we call not the open operation, we call it a trip operation. That's why when the circuit breaker is getting opened, we divide the open operation in two conditions. One is a normal manual open or the normal open, that is under normal healthy condition of the circuit or the remote end. And second is a opening of the breaker under abnormal condition, either on the circuit itself or the remote end, any power equipment or other devices where the power is supplying. If there is abnormal condition, for that if the breaker is getting open automatically, sensing that abnormal condition, then we call it a trip operation. So opening operation of the circuit breaker we actually divide in two parts: normal opening operation, another fault tripping operation. So when we are going to discuss this breaker operation, there are 4 different parts of the circuit breaker operation, tripping operation, that we can divide that tripping operation into 4 different parts. First part is the manual opening or off operation. That also again has a 2 part. One is we can do from the local, another from the remote, that we discuss in details. Second part, this fault operation, fault opening or tripping operation of the circuit breaker, that could also happen in two different ways. One is this particular circuit on which this circuit breaker is feeding power. If there is a fault or abnormal condition on that circuit, then by sensing the fault on that particular circuit, we can open the breaker, can get open. That is one operation. Another operation, there might be a fault to the further outside, that is a remote end. Maybe there is a fire in the remote end. When this circuit is feeding power, then there is a fire and gas signal or ESD signal. Maybe it is feeding power to the other switch gear. That switch gear has developed a fault for which that switch gear might be tripped or not tripped. In that case also we may give the inter-trip to the circuit breaker. That is also another type of fault. So this fault condition tripping again can be classified in two parts. One part is a fault on its own circuits and fault due to tripping of this breaker due to other device fault or other equipment fault or some other reason. So emergency shutdown signal can come, fire and gas signal, which is also ESD signal, can come, or inter-trip for the other circuit failure. This inter-trip can come to this breaker, that is also under trip. So these are the two tripping operation. One is the one tripping operation for his own circuit, another tripping operation for the other device fault or some other fault which is transferred, for which this breaker need to trip. So these are the two tripping operations. So opening operation is to open, normally locally open as well as remote open, and tripping operation is a local due to one fault trip or due to other fault trip. Then another circuit, this tripping coil is very important coil or important operation. If the breaker failed to trip due to some failure of the tripping coil or tripping circuit, then it will be big hazard. And because when the fault current is flowing through the tip coil, it will happen if the breaker is not tripped and the fault current is flowing through not the tip coil, fault current is flowing through the circuit, and due to some failure of the tip coil, if this or trip circuit, if the breaker failed to operate, then due to the fault current there will be high temperature and which can cause a fire. So in that case, that's why we need to supervise the tripping circuit or trip coil continuously, either breaker, whether the circuit breaker is open or closed, so that if there is any abnormal condition in the tripping circuit, immediately we can monitor. In addition to this, there will be another features of this tripping scheme, that is a lockout relay features. Because this tripping scheme, breaker will be on fault, this breaker will be tripped through the tripping relay. And nowadays we are using a very digital relay whose output contact is not highly rated, and there is some interlocking requirement. For that we use another lockout relay. Through the lockout relay, actually the circuit breaker get the fault tripping command. So these are the another feature. So these are the 5 features we have, which we will discuss one by one in these circuits. So not 5, there is 4 features. So what are the 4 features? One is a normal opening operation, tripping operation, trip circuit supervision operation, and the lockout relay operation. We will discuss all this in this video. So let us start from the opening operation. Now I have to save the time, I have drawn the scheme over here. The scheme, the 5 part. The first part, there is a control, because to operate this scheme nicely, you need a control supply. Now we have already discussed switchgear normally get the control supply, that is a DC control supply. It could be 120 volt DC or 48 volt DC. But closing circuit, tripping circuit, alarm indicator, various circuits in that under the switchgear control schematic, there is various circuits, main circuits. Each circuit normally we provide power supply with a separate MCB. So that if this power supply failed for that particular circuit, MCB auxiliary contact we can use for the indication or alarm purpose. So as tripping circuit is also a special circuit, part of the circuit breaker control schematics, that's why we have given a separate dedicated circuit breaker MCB to get the power supply to this panel from the main DC's. So this MCB has auxiliary contact that I have not shown over here. That auxiliary contact, this could be NO or it could be NC. That auxiliary contact we can use for the alarm indication purpose in case of failure. So this power supply is coming to this bus, and this bus is inside the switchgear panel for this particular circuit breaker circuit. Now under this, then the power supply is coming. Now first is breaker opening or off operation. This part is the breaker opening or off position, off operation. That is, I have shown over here. Here, as we have said, the breaker opening operation can be executed either locally. Locally means from the switchgear panel itself. The switchgear where the circuit breaker is located, in case of indoor switchgear, on that switchgear, bottom part of the switchgear panel, generally all the power equipment, and top part of the switchgear is normally all the control components, and the relay, meters, all the control components are located on the top part. So this switchgear, when we need to operate from the switchgear panel itself, that location we call the normal operation. Except that location, if we operate this, open this circuit breaker from the any other location, remote location, like what that it could be remote control room, it could be remote DCS room, distributed control system room, it could be other substation, or it could be a main receiving station in case of HB or EHB substation. So this remote location means except the switchgear panel, if we do the control from any other operation, that location will be termed as a remote location. So in this case, to select whether we to know from where we are doing the operation, we put a selector switch that could be located on the switchgear panel itself. Sometimes it could be located in other location. So that depending on the operational requirement. Here we are considering, suppose this switch is located on the switchgear panel itself, which will be termed as a local switchgear. If the switchgear, if this switch is located somewhere else, then the local remote tagging or designation to be done accordingly. Here we are considering the switchgear panel where the circuit breaker is physically located. The same panel is the local position. This switchgear, this selector switch, local remote selector switch, which have multiple auxiliary contacts, that switch is located on the switchgear panel. Now, here we are, so this local remote we are considering, the local remote selector switch is located in the local switchgear panel, and we have selected the switch in the local position. There are two positions. One is a local position, another is a remote position. This is a selector switch. We can remove the switch either this position or this position. First we see the local operation. So we select the switch in the local position. So the power is coming through this. Then in the circuit breaker, in the local, in the switchgear panel, there is another control switch. That switch we call a breaker control switch. This is called a trip, neutral, close switch. This has a three position: trip position, neutral position, and close position. So this switch, so as we are going for tripping operation, this switch will, during, if we want to open the circuit breaker, we put the switch in the open position or trip position. So that is a trip position. I have shown the three position. This is a trip position. This is a normal, neutral position, and this is a close position. As we go for the tripping operation, so we are selecting this position. This position is wide up. That means the selector switch, we rotate the handle to the trip position. Then immediately this local position, trip position is selected. So this circuit is coming over here. There is a small interlock we have put over here. This interlock, for the case of high voltage and extra high voltage circuit breaker, there is a operating handle. This operating handle, sometime we can stop for the testing purpose or some maintenance purpose or some other purpose. Sometime we need to block the circuit breaker tripping operation. If we want to do that, then we put the rod, so that that operation handle has some auxiliary switch. That switch has been put, that switch auxiliary contact we put over here. That contact is NC contact. This contact, the moment we will block the, will block it, immediately it will become open. As we are not blocking the operation, tripping operation, that's why I put this contact is NC. But the moment we want to block the operation, tripping operation of the circuit breaker due to any operational reason, immediately this contact will get open. So this is a small interlock for the manual intervention, manual operation of the circuit breaker. Then this is coming over here. Now here you see there is a, we have already discussed, breaker has a two type of auxiliary contact. One is a NO contact, normally open and normally closed. Normally open and normally closed, these contacts are designated in the breaker open condition. When the breaker is not closed, breaker is open, at that time breaker has a two auxiliary contact. One is a normally open contact, that is we call 52A, normally open contact, that is normally open contact. And there is another contact 52B, that is we call normally NC contact. So this contact, the moment breaker from the open condition, breaker is going to closed condition, this become NC and this become NO, and the reverse side, when the breaker again from the closed condition it back to normal open condition, then it become NO, it become NC. As the contact we always showed in the de-energized condition, here it is considered as the open condition of the circuit breaker. So this circuit breaker open or closed condition, that also we need to know before tripping the breaker. Breaker opening operation will take place only when the breaker is closed. If the breaker is not closed, then opening operation obviously not coming into picture. So we need to know the breaker is in open condition or closed condition. So when we are opening the breaker, what will be the condition? That at that time breaker is already closed. So that interlock we have put over here with a 52A contact. So the moment breaker is closed, immediately this contact will be NC. So and then it is going to the tip coil. So when we are operating the circuit breaker from the local operation, we put the local remote selector switch, local position selected, locally. So this switch is coming over here. Then here we are now operating the circuit breaker. So circuit breaker will be getting opened. So tip position means open position. So this switch will be coming over here. So power supply is coming through this. Then this interlock is already inbuilt with the circuit. It is coming over here. Breaker is already closed position. 52A. This is also closed. So then the tip coil is getting power. So immediately circuit breaker will trip. So this is the local tripping operation. Now when the breaker is to be tripped remotely, then obviously this switch will go to the remote position over here. So this circuit is coming this way. The power is coming to the remote position. Now in the remote position, I have shown over three. This is one. One means this is a tripping signal is present, and 0 means we use a 1 and 0 combination. 1 means tripping signal is present. 0 means no tripping signal. So from the remote position, the moment we select the switch in the remote position, now there will be multiple remote position. There will be a control room, central control room, or this may be distributed control system room, from where we can give the digital signal, or it could be other control room. It could be receiving a station. Anywhere we can operate the breaker. So if we do that thing, so that's why when I suppose this is your main control room, from there the moment this is in the main control room, maybe this closing operation through a push button. So here it will be a small push button. The moment we press the push button, immediately what will happen? You see the same interlock, it will get closed. Okay, same interlock, it will go from the remote operation. Also this blocking is required. So breaker is getting closed in the breaker is getting tripped in the same way. If we get the tripping room opening command from the another remote location, then this signal will be on. So this contact, so this signal means on, means this will be through. So this signal it may be push button. In case of distributed control system DCS, from the DCS how we give the command? We press the button. The moment we press the button in the desktop keyboard, then what will happening? There is a, in the DCS screen, you can see there is a on off button is shown. So the moment you select this on button or off button, suppose you select the open button, so the cursor will go to the open, then you select it. That means you are giving a soft signal. Then what is happening actually? This soft signal from the DCS is go to the output card, and in the output card there is a output contact, that very low rating contact. That contact is going some auxiliary relay. That auxiliary relay contact is actually connected over here, and that is closing. So this way, in the case of digital signal, we do this thing. In case of electrical manual signal, we use by a push button. We can give the command, or through a switch from the remote position, you can give the opening command. The moment you give this opening command, means it become 1. Then what will happen? This is in the same way. The circuit breaker tripping coil is getting power. Immediately breaker is open. So this is the breaker opening operation from the local as well as remote. So this part is a breaker opening operation. Now we come to the fault tripping. Now I have already said, in case of fault tripping, there are two types of tripping. One type of tripping is breaker own circuit breaker. The circuit breaker on his circuit, the circuit breaker is feeding power. There might be fault on that circuit itself, or the fault may be some other remote end equipments where this power is going. If that fault or some other hazard in the remote end, due to which we need to trip the breaker or open the breaker, that is under, we call it normally trip. So that trip is a two type. When the fault is on the circuit itself, That fault condition is how it is being sensed. There is a CT and VT or PT, you can say, in the circuit, which is sensing the normal current and voltage from the circuit. When this CT is a, CT we have known, CT is a primary, secondary voltage, VT is also primary, secondary. When in the normal condition, the CT output current is a normal current, the moment current goes up or high value above the setting value, then immediately the protection relay operate. Nowadays we have a digital type protection relay. Nowadays we do not use an electromechanical relay. All the relay are the numerical relay. So the digital relay, we give the power CT supply and VT supply to the digital relay, and the digital relay has a program. It can sense the current, then it can compare the current based on the relative current value. The relay will operate, and the relay has a multiple output relays. In one digital relay, there is an input card, output card. Output card means when the relay analyze or compute or calculate that there is a extra high current or some other abnormal voltage or abnormal current in the circuit, immediately for which the fault current is coming, that they can measure it, they can understand, and then during the design of the system, we configure the output. There is a multiple output relays on this particular digital relay, which output relay will operate for which type of fault. Suppose there is a 5 output relay. One output relay we configure for the overcurrent and earth fault. One output relay we configure for maybe for this under voltage of the circuit. One of the output contact maybe we design for the over temperature of the circuit. So depending on the requirement, we can configure these output relays for which purpose it will trip. So that output contact, when it is on, means immediately circuit breaker will understand there is a fault, immediately breaker will trip. How that is happening? That is, we have shown over here. This is actually we call is 86. Now this digital relay output contact, as I said, it is not the high rated, it is a low rating contact, and we need some interlock. Means what type of interlock? The moment the fault takes place, fault is sensed, and the digital relay recognize the fault and it give a tripping command. It out to tripping command to the output relay. Now the output relay we are not directly wiring the output relay of the digital relay output to the tripping circuit. As I said, this is not a low rating, it is a low rating contact, and we need some interlock that till the fault is not cleared, this relay will not allow you to close the breaker, or this relay will remain in the energized condition. So a relay should have some indication that there is a fault existing in the circuit till the fault is not attended by the maintenance people. So sometimes digital relay does not have all this provision. That's why we have a special type of relay which is called the lockout relay. That relay is a very rugged relay. It has a high output rating, current rating, and it has a feature that once the lockout relay is operate, it will not go to reset till you are manually resetting it. That means depending on the maintenance people, once the maintenance people attended the fault, identified the fault and cleared the fault, and then only they will come to reset the relay, then only the relay will allow to further operation. That feature is remains in this lockout relay. That's why we use another lockout relay. That lockout relay circuit I have drawn over here, which is called 86 lockout relay. These are the various protection functions. Suppose this is a P1, P2, P3. Suppose these are the output contact of the digital relay. Suppose this P1 is configured. P1 output of the digital relay is configured for the overcurrent, phase overcurrent fault. So the moment phase overcurrent take place, immediately by sensing the CT supply, digital relay understand there is a phase fault. Immediately this protection function inside the digital relay or the output relay will operate. Suppose this P2 we configure for the earth fault. Then the moment there is a earth fault, it will operate. Suppose this is we configure for the over temperature overload in the circuit, not the fault. It is not the fault, but circuit is overloaded. In that case, this P3 will operate. So when any of the protection operate, immediately what will happen? It will come to another relay. This is the lockout relay. We call this as the two coil. One is a set coil. This coil we call is a set coil, and we call is reset coil. Set coil is energized with the protection. This digital relay protection function. So set relay, it has a this lockout relay. One NC contact is connected through this. So this when the relay is not energized, this it is a NC condition. Then when any of the protection function in the digital relay operate, immediately you see there is a positive power supply over here. Actually, this relay you can connect over here in the positive bus over here. Here you can connect the digital relay, this circuit, and it will be connected to the negative bus over here. Okay. So this part I have shown over here. So this is a positive supply, this is a negative supply. Now the positive supply is connected to the first output relay, which is configured as per our configuration. Then when it is connected in parallel, so when any one of these or all these or any two of these operate, immediately what will happen? Immediately through this NC contact of the lockout relay set coil will energize. Immediately lockout relay will operate. The moment lockout relay operate, then this NC will become NO and this become NC, and it will remain in this way, and you cannot it will not go back to the normal condition till it is this contact it means NC and the normal condition come back. So for that purpose, we have in the relay itself there is a push button, there is a button. This is that button. The moment you press this button, then immediately as this contact now NC, so this reset coil will picked up. The moment reset coil is picked up, this relay will come back to the normal position. It will become NO, it become NC and become NO, and then the relay will back to normal position. This is a special feature of the lockout relay, and this lockout relay has a multiple changeover contact. You know the changeover contact, how we show, that is our changeover contact. So you can say in this way, this is NC contact. The moment it operate, it goes to here. So this has a multiple number of changeover contact. It is a high rating. So that contact we can use for the various tripping purpose, alarm indication, remote interlock. So these are the lockout relay. Now this is the lockout. Now in a circuit, normally in the low voltage circuit, there might be one lockout relay. For the medium voltage and high voltage or extra high voltage, there will be multiple lockout relay. Why we need the multiple lockout relay? Because in the high voltage or extra high voltage circuit, there is a various protection function. Some of the protection function, we group the protection functions depending on their emergency. Like suppose a circuit has a differential relay. Differential relay, when it operates, means it is a sure there is a fault. Suppose there is a transformer. In the case of transformer, suppose the transformer is 20 MVA transformer. So 20 MVA transformer, we have a differential relay. We have a tank earth fault relay. These two are genuine fault relay. There is a Bocos relay, which is also a genuine fault. When the Bocos operates, means there is a genuine fault in the relay. So this type of protection function we put in one group, which is suppose there is a busbar differential relay that has operate. So that is also causing that busbar differential relay when operate, it also trip this breaker, because feeder breaker will be tripped. That is very urgent protection. So this type of urgent protection we put in a one lockout relay, because all the protections we do not put in the same relay. And then we put another lockout relay. That lockout relay may be overcurrent, earth fault, overload, this type of protection function there. Then maybe there is another protection relay, a lockout relay. That lockout relay is sensing the transformer other minor fault, like a transformer over temperature, transformer liquid level low, transformer suppose PRF pressure relief device is operated. So this type of minor condition we generally group in another relay, or maybe some due to breaker failure, other breaker failure, this breaker need to trip. So that maybe we group in the under voltage strip, that put in the another lockout relay. This way also we can use multiple lockout relay. I have shown here two lockout relay. This is one of the lockout relay. Maybe this is the overcurrent, earth fault, all this thing. If that particular feeder has a multiple protections, then the second group of lockout relay is here. So when any of the group of lockout relay operate, any of the protection of the each lockout relay operate, so the corresponding contact will change over and it will make NC. Then the power will come, and when the operation in the fault condition, at that time, you know this, we have already told that how this circuit breaker is connected. There is a disconnector switch. After that, this circuit breaker is there. This disconnector switch has three positions. There is an earth position. If when the circuit breaker is going to fault trip, means circuit breaker disconnector is on and earth switch is not on, earth switch is off. So that interlock we have put over here. the two, as the fault trip will not understand what is the other disconnector position. So that's why we put the arc switch off location. This arc switch has not off, when arc switch is open. So because you cannot, if the arc switch is off, if somebody put the arc switch handle to open it or to make it earth, then that will be danger. So that's why we put this interlock, that arc switch is off condition. It is not on this arc switch rod has not been inserted. So the moment you insert it become open, so even the fault it will not trip. That is a danger. That's why we put a NC condition, and then it is coming to the same logic. Breaker is already closed, so it will go to the tripping coil. So this is the fault trip of this particular circuit. Now, if the fault is not in this circuit, suppose there is a fault on the downstream switch gear or some other equipment or other breaker has failed, or there is an intertrip from the downstream. Suppose there is a fire, and suppose this feeder is feeding power to a remote station where there is a sudden fire. If there is a fire, then the fire signal is going to the fire and gas panel. From the fire and gas panel, it is issuing emergency shutdown signal. So that emergency shutdown signal is coming to this station. Then that emergency shutdown signal can also do the same operation. It can trip this breaker. Suppose there is a intertrip is required. So from that remote substation, they will issue one intertrip command, because there is also a lockout relay. That lockout relay that remote end lockout relay can give a tripping command that we can connect over here, and it will go to the tripping. So this way also, from the other device or other location or emergency condition, this circuit breaker can be tripped. So these are the tripping operation due to the fault in the circuit breaker own circuit, and due to the tripping of the other devices of the or other location fault. If that fault to be transferred and to be tripped this breaker, then that part will be taken care by this. So these are the opening and tripping operation. As then these two functions we discussed already, and each has a two part. Then the third part is a supervision provision. What we said, that circuit breaker, this trip coil, suppose this trip coil is open, that means this is actually a solenoid. This is a solenoid. Suppose if the solenoid open, then what will happen? It will be two part, and there is a discontinuity. Power will not flow, and the coil will not, solenoid will not energize, and it will not able to release the trip. So this will be danger. So that's why we need to continually supervise this trip coil supervision. Okay, let us remove this port so that it will be more clear to us. Okay. So how we are doing this thing? Suppose we are removing this part as well. So how we are doing this part? You see here, there is a relay already we discussed during the circuit breaker closing schematics. The trip coil supervision relay interlock has been inserted in the closing circuit, because if this trip coil has a fault, you cannot close the breaker. If you close the breaker, then breaker will not trip, and at that time, if there is a fault, then the fault current will be continuously flowing. There is a big danger. So that's why trip coil supervision is required. So we are doing by a relay. That relay is called 95 relay. This 95 is a trip coil supervision relay. This trip coil supervision relay has a 3 auxiliary relay or 3 coil inside. One coil is supervising the tripping circuit when the breaker is open condition, and another coil is supervising the circuit when the breaker is closed condition. And if either in open condition or closed condition, in either of the case, if this coil fell, then immediately that particular that particular two coil, that auxiliary contact will energize another relay. If this both open and closed condition trip coil is healthy, then what will happen? There is a third auxiliary relay which is energized by the auxiliary contact of this. If both the coils are healthy, if the trip coil is healthy in both conditions, then that relay will pick up and that will remain energized, and that will give a signal to the remote that trip coil is healthy. But if any one of these get failed, then what will happen? Immediately it will, if the trip coil is failed, then immediately this third auxiliary coil will not energize, and immediately people will be knowing that trip coil is not healthy, that trip coil has failed. So immediately they will take the necessary action. So how is that is working? So this is a first trip coil K1. This is the first coil K1 which is connected to the positive side. This is the coil, and this is going through this. You see here, through the arch switch interlock, it is going, and then it is coming over here, and it is a breaker NO contact. So when the breaker is closed, this contact is NC. So through this path, K1 coil is getting energized through this path, and through this it is going power. This really has a special features. This K1, K2, K3 coil has a high burden, very small leakage current normally flow through this, so that it will not damage the trip coil. So this coil current is passing through this, and though K1 is energized, so K1, when the breaker is closed, K1 will always remain energized. Okay. Similarly, when the breaker is open, at that time this contact is, when the breaker is open, at that time this contact is NO. So the power cannot flow through this because there is a NO contact, right? So it cannot flow through this. So what we will do at that time, we use breaker NC contact. This is NC contact with 52B contact that is getting energized through another coil. You see, this is a K2 coil, then K1, then the power will not flow through this way. It will come through K1, then through the K2, it will come, and then 52B auxiliary contact is going to the passing through the tip coil. So in that case, K1 and K2 both remain energized. Okay. So when this breaker is open condition, closed condition, only K1 is energized. But when the breaker is open condition, at that time tip coil is supervised by both K1 and K2. So if the tip coil is not filled, either K1 or both K1, K2 remain energized. So this K1 and K2, that two auxiliary NO contact we have used over here, which is energizing another relay K3. This K3 relay auxiliary contact, suppose this is NO contact, this K3 is always energized. Whether breaker is open or breaker is closed, it is energized. How? When the breaker is closed, K1 is energized, so K1, this path is through. When breaker is open, at that time both K1 and K2 both are energized, so this K3 is remain energized through both the path. So this 95 is a always energized relay. For any reason, if the 95 drop, when the 95 can drop, if the trip coil is filled, immediately what will happen? The moment trip coil is filled, K1 and K2 both will drop, because K1 and K2, whether it is coming through these or coming through this, it is ultimately passing through trip coil. So it is not passing, when the moment K1 and K2, the moment this tip coil is filled, power is coming through either K1 and K2, but it is not passing through the tip coil. So this K1 and K2 will drop, and the moment it is dropped, it become NO, and the 95 will drop, and the remote signal will become open, so they will not get the healthy condition. That means tip coil has filled. So that is the tip coil supervision relay we use in the tripping scheme to monitor the trip coil. Okay. In addition to this, there is another small, in the tripping circuit we show one, we do not trip the breaker, but we monitor if the protection relay fail. In that case also we monitor the relay sometime. The protection relay, digital nowadays protection relay has a watchdog contact. So watchdog contact, if the watchdog contact operate, that means the relay has failed. At that time we need to, depending our requirement, we have to decide whether the watchdog contact will use for the tripping purpose or not tripping purpose. In the digital relay also another option is there. In this tripping part here, we can add the digital relay direct output. Yeah, direct output we can use in the lockout relay also. That is if digital relay is configured in that way, that depend on this, but it is always we always use the digital relay output contact we use in the lockout relay, and then the lockout relay will get tripping. So these are the various parts of the tripping scheme. So in a brief, what we said, in the tripping scheme we have opening operation, that is from the local as well as remote. In the tripping scheme we have the remote fault tripping scheme. That in the fault tripping scheme has a two part. One is a circuit, this circuit for which the feeder is feeding, that one circuit fault, as well as remote end fault or the other equipment fault for which this breaker is tripped, that also captured. Then the trip circuit supervision arrangement there, and the lockout relay provision is there. So these are the various features of the tripping scheme that is we discussed. So please go through this. If we have any queries or question, please you can raise your flag and we'll try to address. With this, I am closing this tripping scheme over here, and thank you very much. Be a partner to our joint session, this knowledge sharing session, and hoping all of us will be continuing in the same manner and with the same speed. Thank you very much indeed. Thank you.